video. Here I am taking a reference circuit diagram for the understanding of supernode analysis concept. In order to apply supernode analysis technique, we have to keep remember a solid key point. If a voltage source exists between two non-reference nodes, then supernode analysis technique will be applied to solve that problem. And in order to apply supernode analysis technique, we have to merge that voltage source to any one of its adjacent node voltages. Whenever we will merge voltage source to its adjacent any node voltage, that node will act as supernode. Now we will learn about how the voltage source is merged to its corresponding node voltage. For better understanding, we will take this part of the circuit in order to form a supernode. Here a 12 volt source exists between two non-reference nodes. Now as we are dealing in simple nodal analysis technique, voltage across any element between two nodes is always equal to the difference of those two node voltages. In this case, voltage across this voltage source is 12 volt, which is indicating that the potential difference of these two node voltages is 12 volt. So we can write this statement in mathematical form. Potential difference of these two node voltages is equal to 12 volt. We will consider both cases, and in both cases the voltage equations will be same. In first case we are considering voltage V2 is on higher potential than voltage V3. So the direction of current will be from V2 to V3. V2 minus V3 will be equal to minus 12 volt. Here the direction of current is from this node to this node, and current is entering from negative terminal. That's why this 12 volt is taken with negative sign. Now if we want to merge the value of this voltage source towards this node V2, then using this equation, the equation of voltage for V2 will be equal to V3 minus 12 volt. Similarly, if we want to merge this voltage source towards V3, so using this equation again, the equation for this node voltage V3 will be equal to V2 plus 12 volt. Now we will consider another case where voltage on V3 is on higher potential than voltage V2. In this case, voltage difference between these two node voltages will be equal to V3 minus V2 equal to plus 12 volt. Here V3 is on higher potential than V2. It means the direction of current is from V3 to V2, and the current entering terminal is positive. That's why this 12 volt is taken with positive sign. Now using this equation, we can merge this voltage source either to V3 or V2. If we merge the value of this voltage source to node V3, then using this equation, V3 will be equal to V2 plus 12 volt. Similarly, if we merge this voltage source into node V2, then V2 using this equation will be equal to V3 minus 12 volt. You may see that in both cases the equations for V3 and V2 are same. After calculating node voltage equations including voltage source value, we can form supernode on these 2 points. In this first diagram, 12 volt source is merged with V3 and V3 is replaced with its equation V2 plus 12 volt. Similarly, in this second diagram, 12 volt source is merged with V2 and V2 is replaced with V3 minus 12 volt. After merging the voltage source to either node, this node will act as supernode and it will be considered a single node inside the network.